We're going to convert between logarithmic and exponential form, and then also solve logarithms by changing to exponential form and then getting the same bases. The base of the exponent is going to be the base of the log. So that's going to be log base 2. And then you hop over to the other side. Of 8 equals hop back 3. So one more example, 5 squared equals 25. In logarithmic form, that would be log base 5, because that's the base of the exponent. It's going to be the base of the log, of 25 equals 2, the exponent. Convert to exponential form, then solve for x. So base of the log is the base of the exponent, 3 to the x, that's your exponent, equals 81. And if you didn't have an x there, in the problem, if you just had log base 3 of 81, I would just put equals x. Now we want to try to get the same bases. 81 can be written as 3 to some power, and it's going to be 3 to the 4th. Now that we have the same bases, we can set the exponents equal, so x equals 4. The next one, same thing, write it in exponential form first. 8 can't be rewritten as a 1 to some power. 1 to any power is just going to be 1. But 1 can be rewritten as 8 to a power. That's 8 to the 0. Anything to the 0 is 1. But now we have the same bases, so x equals 0. And you might have been able to tell off the top of your head, 8 to the something equals 1. That has to be a 0. The next one we can write in exponential form. 1/5 to the x equals 125. Don't try to make your base a fraction. Rewriting 125 as 1/5 to some number is going to be hard to think of. So I would try to get both of those to be a base 5. The exponent right now of the 5 is just a 1. So in order to bring the 5 to the 1 up, you make the exponent negative. Still to the x outside. 5 cubed is 125. 5 times 5 is 25 times 5 is 125. You can do that in the calculator by guessing and checking. So now we have 5 to the negative x equals 5 cubed. So that means negative x equals 3 when you're looking at the exponents. So x equals negative 3. The next one, 49 to the x equals 7. Out of a 7 and a 49, I would get them to have base 7, your lower number. If you tried to rewrite 7 as 49 to some power, that's going to be harder than rewriting 49 as 7 to some power. So 49 is 7 squared, but we still have that to the x equals 7 on the right. When you have a power to a power, you multiply the powers. So 7 to the 2x equals 7. The exponent here is just a 1 if you don't see one. Now that they have the same bases, 2x equals 1, so x equals a half. And then finally for this one, 2 to the x equals 1/64. Let's try to make the bases 2. 64 is the same as 2 to the 6th, and then you can bring the 2 to the 6th up by making the exponent negative. Another way you could have done that is you could have brought the 64 to the 1 up first, so 64 to the negative 1, and then 64 is 2 to the 6th, so now you have 2 to the 6th to the negative 1, which ends up being 2 to the negative 6. So then we have x equals negative 6.